Dear friends, this is my tutorial 31. In this tutorial I am going to teach you how to do and plot anharmonic VCD spectra of S-methyl oxirane using Gaussian and Multiwfn softwares. So this is the anharmonic VCD spectra of S-methyl oxirane. So next we will see how to make input file for this VCD spectra calculations. So this is our folder for geometry optimization and VCD spectra calculation folder. First we will see the input files for geometry optimization of S-methyl oxirane. Okay. So this is the S-methyl oxirane optimization folder. So I will show you the input file. So this is the input file for S-methyl oxirane. Just open with Notepad++. So this is the input file. So first you have to give the name of the system. That means you have to mention percentage, then chk equal to the name of the system, then .chk. Then you have to give the memory and nproshat. So if you are using Linux environment, this may vary. So if you are using Windows version, just you can use 6mw nproshat 2. This is enough. Then you have to mention the theory, which theory you are going to use. So I am using here B3LYP. So this is the generally I will use these keywords in the root section. Then we have to mention optimization frequency keyword. So first the calculation will run optimization. After completion of this optimization of the structure, then it will run the frequency calculations. So then you have to give the space. Then you have to give name of the system. Then give one space here. Then you can give the spin multiplicity charge, and so this is the charges of the system. So this is the spin multiplicity of the system. So the spin multiplicity 1. So this is the Cartesian coordinate of that S-methyl oxirane. So then you have to give space. Then you have to mention that what are the atoms present in the molecule. Here the carbon, oxygen, H is there. So after completion of this H, you have to mention 0. Then you have to mention the basis set. Which basis set you want to use for this optimization of this S-methyl oxirane, just you have to mention. So for light atoms, I simply use this basis set only, 631 G star. Then you have to give 4 star. If you give 4 star means this is the end of the basis set. Okay. Then you have to give the enters to get some space. Then only that Gaussian will think the input file will completed, it will run. Otherwise you will get some. Then save it. Then you can submit this calculation to your Windows system. It will complete within 10 minutes because this is a very small system. I will show you this input file using the Gauss view also. Open your Gauss view. So just drag that input file, S-methyl oxirane. So this is the S-methyl oxirane input file. Okay. So you have to submit this input file your system, then you will get that output file. So this is the output file for S-methyl oxirane. So we can also view using this Gauss view. Just we can drag this into that Gauss view. We will see that optimized geometry. So this is the optimized structure of S-methyl oxirane. So I will show you this output file using Notepad++ also. So this is the root section. Root section key will print in that output file. So if you go down, you will see the normal termination of Gaussian 09. Okay, that means your system is completed, optimized without any error. So next what you have to do, you have to save this optimized geometry for further anharmonic VCD spectra calculation. So if you are doing any other single point calculation, you have to use your optimized Cartesian coordinates. Yeah, I already saved that optimized Cartesian coordinate and also did my VCD spectra calculation also. So I will show you that VCD spectra calculation folder. So this is the VCD spectra calculation folder. So this is the VCD spectra input file. So just we will open with Notepad++. So this is the VCD spectra input file. Here you can see similarly what we use that optimization, similarly we have to use up to here. So actually here you see I used memory 20 GB and enforce at 40. That means I used this calculation in Linux system, and also a Gaussian 16 I used for this calculation. So then that's why I mentioned like this. Then we have to give the theory, what theory you want to use, just mention here. Then it's the general keyword you can give. So this is the very important for anharmonic VCD spectra calculation. So if you did not mention that anharmonic, it will default run that harmonic VCD spectra calculation. So here you can give freq and open bracket VCD comma AN HARM close the bracket. So this is the anharmonic VCD spectra keyword. So anharmonic VCD spectra you can do in the Gaussian 16 only. So Gaussian G09 we cannot get this anharmonic spectra. So you have to use Gaussian 16 to get that anharmonic VCD spectra. Then you have to give the space. Then you have to give the S-methyloxyren name of the system. So I always mention here VCD because which calculation I am running, that I can know easily. If you mention some name here, VCD means VCD, NBO means I will mention NBO. So population analysis means I will, MO means I will mention MO. Like that, which calculation I'm running, just I will give the name after that system name. So likewise you can also do it. Then give one space. Then the default the total charge of say the system is 0. Then you have to give the spin multiplicity 1. So this system spin multiplicity 1. Then you have to use the optimized Cartesian coordinate here. So you have to take this Cartesian coordinate from that optimized output file. Then you have to give the space. Then you have to give what are the atoms present in the molecule. Then you have to give 0 after completion of this. So then what you have to do, you have to give your basis set. Then you have to give 4 star. Then you have to give enter in order to get some space. This is very necessary. Always you can do like this. Then you can save it. So now we have prepared our VCD input anharmonic VCD spectra input file. So just you can submit this with your Gaussian 16 software. Then you will get that corresponding output file. That means anharmonic VCD spectra output file. So this is that anharmonic VCD spectra output file. Just I will open with Notepad++. I will show you. So this you can see here I used Gaussian 16 software to do the anharmonic VCD spectra. So here this is the root section keyword. If you come down, you will see normal termination of Gaussian 16 calculation. That's how our system is completed without any error. So we can use this optimized output file to get our VCD anharmonic VCD spectra. Just we can close this one. So now we will execute our multi-WFN software. So this is the multi-WFN software folder. So if you want to download, this is free only, open source version only. Just you can visit Google, just give that multi-WFN. You will get different kind of versions. So if you want Windows version, just click it Windows version, it will down. So we no need to install this multi-WFN. This is directly executable. Just you can double click this. So you open that folder and just you see this is the application. Just to double click, it will open. So now we have to press enter. Then only it will start. Enter. It will ask which folder you want to choose. Okay. So this is the spectra folder. Here only I did that anharmonic VCD spectra calculation. This is that folder. So this is the VCD anharmonic VCD folder. Just we can open it and just we can select this one. S-methyloxyren VCD output file. We can open by pressing this. So now it will open main function menu of that multi-WFN. So now we what we have to do, see here option 11. So option 11 means plot IR, Raman, UV visible, ECD, VCD or NMR spectra. So we have to type 11 and enter, and it will ask select the type of spectra to plot. So here you can see, so different kind of option is there. So we want only the VCD. Okay, so this is the VCD. 5 we have to choose. Just type 5 and enter. So here you can see recognized as a Gaussian output file, found anharmonic data. If you load then instead of harmonic one, so we have to type Y. Yes means it will load anharmonic data. So type Y and enter. So if also load overtone and band frequency, so I don't want this one. So it's a this harmonic data is enough. If you want, you can also give this yes. So I don't want, just I will mention n. So if also load combination of bands frequency, it will ask. So this also I don't want, just I will type no. So now we have to give the scaling factor for vibrational frequency. So now you have to choose 14. Just press type 14 and enter. So here there are 24 frequencies in total. So just you can enter, it will select all the things. So now we have to use scale factor. So earlier video also already mentioned that how to get that scale factor, even though I will tell you in this video. So go to Google. So type vibrational frequency scaling factors. If you type this one in Google, you will get this one, CCCBDB. Just click it. You will get the scaling specters. So this is the density functional. So here you can see we using a B3LOP. So 631 G star base set only using. So we have to use this scaling factor value 0.960. So if you are using other theory and a different basis set, accordingly you have to choose that one. So that's all here. So here we have to mention 0.960. Then you have to enter. So I think we came into the calculation. So now we can see our plot. So now you can see 0 to plot spectrum. Okay. So type 0 and press enter. You will see your anharmonic vibrational VCD spectra of S-methyl oxyurine. So if you want to save this file into your corresponding folder, we can also save it. We can close before that one. Just you can right click, it will go. Then you can see option 1. Option 1 means save graphical file of the spectrum in current folder. Just you can type 1 and enter, it will save. So if you want XY data set lines curves to plain text file, we can also get. So using this one, you can use your origin software in you can plot easily. Okay. So for that we can type 2 and enter. So file automatically saved into that our VCD spectra calculation folder. So we will see. So you can see here. So this is our corresponding folder. So you can see here that curve and line spectra file also saved. So you can use this file to plot using origin your anharmonic VCD spectra. So this is the file, the multi-WFN saved graphical file. We can double click and you can view this file. So you can also use this for research purpose. Otherwise you can use that origin to replot your anharmonic VCD spectra in order to get good views. That's all. This is very simple. So you do this kind of calculation with the different chiral molecules. You can get that this kind of spectra, VCD spectra, anharmonic VCD spectra. Thank you for watching my video. If you like my content, please like, subscribe, comment and share, and also please click the bell icon for my future video update. Thank you so much. Thank you for your time and support. Thank you.